Next up is Bruce Weyer. He is the corporate VP of Microchip's FPGA business. And this is where he's responsible for the unit's operational execution, strategy, and growth. By the way, there might be some more seats available. I love seeing the packed house, but I want you all to be comfortable. Squeeze in, folks. So Bruce is a semiconductor industry veteran with more than 35 years of experience. And today, he's going to explore the imperatives of 100G intelligent edge and how new compute capabilities driven by RISC-V deliver to these imperatives. Please join me in welcoming Bruce to the stage.
Good morning, everyone. It's great to be back with you again here at the RISC-V Summit. And what an exciting time for our industry with this convergence of compute and automation and the advent of intelligent technology. And this incredible opportunity to accelerate learning in nearly every occupation. The ability to extend the reach of this technology and the importance of keeping this in a secure fashion, with the responsibility of taking intelligent technology and having a secure relationship and a co-piloting of the technology. And in this case, you normally think about big data. You think about training algorithms that have to be capable of managing the biases and the incompleteness of data. You think about integrity in this process. But the reality is that 75% of this compute is not going to be in big data. It's going to be on the intelligent edge. And the criteria for the intelligent edge is slightly different. You're not creating the training algorithms, but rather you're inferring these algorithms. You're calling the algorithms. You're trying to make intelligent real-time decisions. And security is not ensuring there's no bias in an algorithm, but rather how do you secure your hardware platform at the edge? How do you ensure that you have physical security and you're building layers of protection about your IP on the edge and the data at the edge? So Microchip has a tremendous focus on edge technologies. Many people don't realize that we ship over 1 billion hardware security devices a year. So we have a tremendous focus on how do you physically secure products. We have a lot of technology and understanding about that. We also ship billions of microcontrollers and analog devices and sensing technologies that build the foundation of intelligence and represent the really broad reach of intelligence at the intelligent edge. But today, I'd like to focus on the higher level of integration that we have within our Microchip FPGAs and how we have a platform that can secure and deliver an intelligent edge with a bandwidth up to 100 gigabytes of information. How we can offer multiple concurrent neural networks that are interoperating with real-time streaming data, 8K video information to make real-time intelligent decisions. And how we offer the most secure platform in the industry, and we have for decades. Security in the natural sense of being immune to energized particles that could create single event upsets in a fabric. The capability of ensuring that you don't have a glitch in an autonomous vehicle or in the plane that you're flying within. And having the highest level of security built into our fabrics for physical layer security. Puffs, cryptographic accelerators, meshes, an entire plethora of anti-tamper capabilities, having the deepest layer of physical security available in the product in order to build on that your design and data levels of security. And doing this at a very low latency, high throughput capability to support 100 gig type application spaces. And when we delivered this technology, it was really important for us, being a FPGA that's all about flexibility, to ensure we also had a very flexible compute stack within it. So we've been a very early adopter of RISC-V because it allowed us to innovate. In 2016, we introduced our first RISC-V solutions with soft MCUs that could be designed within our Smart Fusion 2 and PolarFire architectures. We then extended this reach with PolarFire SoC, which had hardened complex of quad-core processors that allowed asymmetric multiprocessing. So each of those processors could either run and can either run Linux or real-time applications. We also introduced our Mi-V RISC-V ecosystem. Today, Mi-V enables over 95% of commercial and open operating systems to develop with our products. And last year, you may have heard the presentation from Pete Fiacco from JPL. Now NASA and JPL are partnering with Microchip to deliver the next generation of high-performance spaceflight computing to advance space exploration for the next decade. And we also previewed our PolarFire 2 FPGA platform. For the past 6 years, PolarFire has offered twice the power efficiency of competing FPGAs. And as our competition is trying to catch up with PolarFire, we are doubling our power efficiency again with PolarFire 2. We're also doubling the performance of our fabric, which offers great flexibility. You can double your performance for the same power efficiency, or you can run it at the same performance with much lower power consumption. We also are extending our reach with 20 times more bandwidth in machine learning and signal processing type applications. We're extending the reach of RISC-V in the market. And we're very excited to extend the flexibility of our technology now with PolarFire 2, with the embedding of vector processing blocks throughout our fabric. So you have the flexibility of access to a very high-performance FPGA fabric. You have the access to customization and further optimization with embedded vector processing blocks, and then, of course, also the microprocessing subsystem that is going to be resident within PolarFire 2. I'd also like to recognize Richard Newell, a fellow at Microchip that's been has been the chair of the Cryptographic Extensions Task Group, which has currently been ratified, and I want to thank that entire team for continuing to bring the highest levels of security to RISC-V implementations. So if you look at the extension now of asymmetric processing, this concept of each microprocessor being able to do Linux or real-time, here's some examples of applications for industrial automation. You may want all 4 of your cores running Linux. You may want 2 of them running bare metal and 2 of them running Linux. You might want to focus on lockstep for safety critical applications along with your Linux. Or you might simply want to have 5 separate cores capable of doing real-time calculations, 4 in the processing plane and 1 in the microcontroller plane. But the reality is every system is vulnerable to a physical attack. For as low as $400, your platform can be attacked in a way that's meaningful and will bring your system into risk. And as you move forward, quantum computing is capable of breaking asymmetric cryptography. So it's very important to have a focus not just on cybersecurity, but the entire physical security stack. And it starts with the hardware. For the past 6 years, Cisco and Microchip have been partnering together to ensure that Cisco's routers and switches are the most secure in the industry. Cisco relies on our SmartFusion 2 FPGAs to be the root of trust of the routers and switches. We bring up the entire system. We've partnered together on ensuring that there's secure programming hardware environments such that as they insert their intellectual property, it is secure. That when we insert encryption keys, there's no human intervention. So you have secure hardware, you have secure IP layers, and on that, top of that is where you and I recognize the security of our information going through their routers and switches. Likewise, and in parallel, the UK's government for National Cybersecurity Center ratified our PolarFire architectures, that we meet their rigorous requirements for their security, for the national security. So we have a long history of leading in hardware design and data security for the industry. This security is available today. This security layer is available today for anything from the intelligent edge to communications, aerospace and defense, all the way into space. And it's on this basis that we're building our next generation of capabilities for quantum resistance and extended and enhanced anti-tamper capabilities on their PolarFire and PolarFire 2 architectures to make sure that we're leading in the post-quantum secure business. So we're really excited also to be bringing RISC-V to the masses. We've been partnering with BeagleBoard, and I want to thank the BeagleBoard team for helping us bring the BeagleV Fire platform to the market. It allows you to work with a single board computer capable of loading immediately with Linux. It has extension capabilities with the Cape header to bring on your favorite daughter cards. And it's debuting our PolarFire SoC architectures at $149. They're available today at your favorite distributor. And we're giving demonstrations of this platform in our suite, in our booth on D2. I'm also very excited to announce that in the next 90 days, we're entering an early access program for PolarFire Studio. PolarFire Studio is our brand new redesigned design environment for both our FPGA, within the FPGA, as well as system-level capabilities for high-level synthesis, AI/ML, and embedded. In the next 90 days, key customers and key partners are going to start designing with PolarFire 2. We're also very excited to announce that Microchip is entering into the standalone 64-bit MPU business, inclusive of RISC-V architectures, and we'll be dialoguing more about that later this spring. So thank you very much. It's great to see you again, and I hope to see you in our booths. We'll be demonstrating not only our new software platform, but also the BeagleBoard environment. Thank you very much.